Alright, so problem 1 is provide the missing reagents or products for A through C and propose a few mechanisms. So let's first look through the various reactions and make sure that we understand the products that are being formed. So here, this is standard nitration, but you see that you've put one nitro group on, and then under these conditions you've put a second nitro group on. So remember when we were talking in lecture about this, is that the first nitro group will be meta-directing. But in addition to that, it deactivates the overall ring. So the conditions for this are going to have to be pretty harsh. So it's going to have to be HNO3, so nitric acid, and then fuming sulfuric acid. And this is an important distinction in this reaction. So then we have this molecule, and again, how is this going to be? Are these groups going to be ortho-para-directing? Are they going to be meta-directing? They're going to be meta-directing. So from each nitro group, the ortho are the same, and then the open meta site is here. Right, so it's still meta-directing. And again, so what is this reaction? This is a Lewis acid that will take this tert-butyl chloride and then convert it to this incredibly strong electrophile. And then the mechanism goes through the same way to give you this intermediate product, which will look like this, with your tert-butyl group added at the meta position with respect to the two nitro groups. So these are conditions which are talked about in your book, but based on the lecture that was just presented, you could also include other conditions that would reduce an aromatic nitro group to an amine, such as hydrogen gas and palladium or platinum. So here again, if you look at what's going on, you really don't even need this chemical formula to predict what your product is going to be here. That you're going to undergo aromatic bromination, and now you have kind of an interesting situation. So here you had meta-directors, but when you reduce them to the amines, they become ortho-para-directors. So if we look at where is this going to direct, it's going to activate this, this, and this site. This one is going to activate this, this, and this site. And also the tert-butyl is going to activate this, this, and this site. So the tert-butyl is going to activate ortho and para. Each amine will activate ortho and para. So then the question is, if you're going to add one bromine to this, where will it add? So then if you draw this tert-butyl group in its full glory, then hopefully you can recognize that these two sites, so all of these sites are equally activated, but these two sites have larger steric demand because of the tert-butyl group, and consequently your bromine will go this position to give you this product here. imagine you can't see that writing. There's a torpedo group there. Okay. So then you look at mechanistically how these things are going to happen, and I tried to put together a pretty detailed mechanistic description here. And I think the important thing to make note of here is that when you look at the nitrosylation of benzene, remember that this is the active electrophile in this reaction. And this just depicts the mechanism by which you get to that active electrophile. And then you have nucleophilic attack by the one of the pi bonds of the aromatic ring. That leaves a situation where you can very readily undergo elimination. And then the question is, which of these positions will then react further? And remember that this is a meta. Once you have this single nitro substituent, this is going to be a meta director, and that is, so what is being explained at the bottom here is why it is a meta director. Okay. So subsequently we're going to react this dinitro compound with tert-butyl chloride treated with a Lewis acid. So you form the Lewis acid Lewis base complex, and then that leaves to give you this tert-butyl cation that can react, that can be the effective electrophile in the reaction. Okay, and then mechanistically it happens the exact same way that it's been occurring. So there might be a cattail that might come through in a second. And then conversion of 3 to C. I talked about it already, but what you can see here is that all of these groups, both amines and the tert-butyl group, are all orthopara directing, and so all of these positions are orthopara to all the substituents on there. And so reaction wise, it's going to happen in the exact same way, is that you'll have a strong electrophile, and then one of the pi bonds of the aromatic system will react, and then you have a non-aromatic system which you can eliminate hydrogen to bring back your aromaticity. Okay. And Priscilla and her brother Elvis.